And thanks for joining us. If you've just finished watching our Architecture All Access videos on AI, then you've come to the right spot, as we're now going to dive into some details about the AI work going on here at Intel. But if you haven't seen those videos yet and you want to brush up on some concepts around AI fundamentals or AI hardware and software, the links to all those videos are in the description below. We're fortunate to have Andres Rodriguez, an Intel Fellow and AI Architect, and Huma Abidi, Senior Director of AI Software at Intel, joining us. First of all, thank you both so much for being here. And by the way, those were some great AI videos. Now, Andres, when people think about AI, a lot of times the first thing they think about is GPU, but that's not necessarily the best way to think about AI, is it?
That's correct. Let me first explain a little bit of why there is that perception. I think there are two primary reasons. First, there are some people that associate AI with just deep learning, but AI is much bigger than this. And I'll talk about the other areas in just a moment. But second, it has to do with some history. When this wave of AI started, the software was not optimized for CPUs. And so the early adopters got suboptimal performance when they ran deep learning workloads on CPUs. And it created this perception that you needed GPUs. However, over the past several years, Intel has heavily invested in accelerating the software so you can get good performance for deep learning inference and deep learning training. In addition, Intel's adding specialized acceleration to our general purpose CPUs. For example, in this generation of Intel Xeon scalable processors that are going to be launching this year, which we call Sapphire Rapids, Intel added an accelerator to every single core so that you can get a significant boost in performance. But also going back to the first point that AI is much bigger than just deep learning, a lot of the traditional machine learning runs very well on CPUs, both training and inference. Intel's also optimizing those libraries that are widely used in the market for machine learning, like scikit-learn, NumPy, Pandas, XGBoost, and many others.
Huma, implementing an AI solution, it takes a lot more than just great hardware though, right?
Absolutely. So for exceptional hardware, you require exceptional software. And it is our job to make sure that we provide our AI developers with highly optimized performant libraries for their end-to-end solution. And by end-to-end, I mean different stages of AI end-to-end workload. For example, data engineering, creating a model, training a model, deployment. And so, for example, we have our AI analytics toolkit, which has these popular frameworks such as TensorFlow, PyTorch, XGBoost, all of them optimized on our Intel hardware, taking advantage of all these hardware innovations. Similarly, we have a big DL that helps data scientists to create distributed AI workflow. So we have many software solutions which go along with the hardware innovations.
Andres, in your Architecture All Access video, you talked about CPUs and GPUs, FPGAs, and custom accelerators. What is Intel doing in each of these areas?
So as I mentioned, in CPUs, we're adding specialized acceleration to every core of our CPUs. For customers or end users that require specialized acceleration, more dedicated compute than what is available on the CPUs, we developed a specialized deep learning training accelerator called Gaudi or Habana Gaudi, which is available to the broad market on AWS, for example. We also developed Habana Goya, a dedicated inference accelerator. For end users that require a mixture of HPC and AI, we're developing a dedicated compute GPU called Ponte Vecchio. And for customers that have FPGAs, we've also optimized our libraries so that they can run AI on their FPGAs. Of course, all of these hardware features require software, as Huma was mentioning. And we invested in software to make sure it runs well across our various hardware backends.
It's not just Intel pursuing this heterogeneous strategy, though, is it?
That's right. There are other companies that are investing in multiple hardware. Artificial intelligence is growing exponentially. It's going to be growing across every industry, across multiple applications. And this is very good for the well-being of humanity, and Intel wants to contribute to this. Therefore, we are adding AI features to many of our hardware products, not just with hardware acceleration, but also with software acceleration.
Huma, so many different architectures, that's got to be just a huge challenge for software.
Indeed. So all of our software libraries, optimizations for AI workloads are based on the foundation of open standard-based unified programming model called OneAPI. Now, OneAPI helps developers deploy their AI models quickly and in an efficient way across heterogeneous architecture. This actually eliminates the need for having multiple code-based programming languages, APIs across different architecture.
Andres, so many different architectures to choose from with Intel. How does a customer make a decision?
Well, customers should always start with a CPU. So our CPUs are general purpose, and they can support a broad range of models. In addition, because we're adding specialized AI acceleration, then that boosts in performance for deep learning training, for inference, and all the software optimization that we're doing across machine learning, traditional machine learning, and deep learning gives special strength to the CPU. Now, there are some workloads that benefit more from more dedicated compute. And then depending on your deployment environment, you might then adopt one of our specialized, more dedicated compute hardware like Gaudi, Goya, Ponte Vecchio, or our FPGAs.
Huma, how does a customer make sure that they're going to get the best performance out of their hardware?
So, Jason, we've been working tirelessly to make sure all the popular frameworks for machine learning, deep learning, as well as our own tools are highly optimized, taking advantage of, as Andres mentioned, the hardware innovation, the hardware features such as AVX512, Deep Learning Boost, and upcoming features that for Sapphire Rapids that Andres mentioned. And what we do is after we make these optimizations, we want to make sure that they are upstream to the main line. For example, TensorFlow, PyTorch, XGBoost, and we are making that default, those optimization default on CPU. So by using that, you can get from 10x to up to 100x performance boost. We also have other things like OpenVINO for deep learning inference. We also have quantization tools. So performance is very important to us. And we want to make sure our software is highly optimized for our AI developers.
Andres, the newest recommendation models are pretty complex. So how does a customer choose the right architecture when those models are getting more complex?
Jason, it's not just recommendation models that are growing complexity. Also, language models and other deep learning models are becoming more complex. You no longer have just a bunch of matrix multiplications that are highly parallelizable, but also a lot of code is serial-based. And so you need an architecture that can balance the general purpose compute with this specialized compute. And this is one of the strengths of our CPUs.
Huma, I know your team's been putting a lot of work into something called Intel Neural Compressor. Can you tell us more about it?
Absolutely. So data scientists and machine learning engineers are always finding ways to optimize models for deployment, inference deployment. The techniques such as pruning and quantization may take days to get optimal model size and performance. So to address this, my team has created Intel Neural Compressor, which is an open source library, and it automatically does pruning and quantization across popular deep learning frameworks such as TensorFlow, PyTorch. And besides giving great performance boost, it also ensures that there is minimal loss of accuracy and productivity up to an order of magnitude. So this is part of the Intel OneAPI Analytics Toolkit. There are other tools such as OpenVINO, which also have this capability of pruning, sparsity, and quantization in POT, as well as NNCF tools that they provide.
Perfect. Huma, Andres, thank you both very much for being here. This has been terrific. If you're currently working on an AI project or have an AI project coming up, we hope you'll consider Intel. If you want to get started with AI at Intel, check out software.intel.com/AI, where we have a lot more information about OneAPI, the Intel Neural Compressor, Intel DevCloud, and more. The links are in the description.